Hi and Assalamualaikum. So today our group would like to present about technique of differentiation, program CS110, subject MAT186, group CS1102D, prepare for Sema Mat Yasar bin Yusri. Next is the word distribution. Nurul Izazi Hazira binti Kamal Afandi for question 1 and conclusion, Siti Nur Hidayah binti Mama Azlan for question 2G, and Afifah Alia binti Azman for introduction and question 3D. To give you the clear roadmap of our presentation today, we have organized our video into 3 segments to fully address our assigned tasks. First, we will establish our theoretical foundation by going through the exact meaning of differentiation and exploring the core technique in our calculator's box. Second, we will dive into our practical application by solving question 2G, where we will find the explicit derivative of a radical product function. Third, we will tackle question 3D, applying implicit differentiation to solve an equation where our variables are closely intertwined. Finally, we will wrap up our core conclusion and recommendation. Let's begin with our first segment. I will hand the floor over to Izazi to take us through the conceptual meaning of differentiation.
Differentiation is a process in calculus used to find the rate of change of a function with respect to a variable. The result obtained is called the derivative. Geometrically, the derivative represents the gradient of slope of the tangent line to a curve at a particular point. There are 9 techniques of differentiation. First is the power rule, used for function in the form of x raised to a power. Second is the constant rule, where the derivative of any constant is 0. Third is the quotient rule, used when one function is divided by another function. Fourth is the chain rule, applied to composite function, which means a function inside another function. Fifth is the product rule, used when two functions are multiplied together. Sixth is the trigonometric rule, which involves trigonometric functions such as sine, cosine, and tangent. Seven is exponent rule, used for exponential functions such as e to the power of x. Eight is the generalized power rule, which combines the power rule and the chain rule. Finally, the logarithmic rule is used for the logarithmic function, especially natural logarithm.
Thank you, Izazi. Now I will be presenting the step-by-step solution for our first practical problem, which is question 2G. We are required to find dy over dx and completely simplify the following function, which is y equal x squared square root x negative 6. To make this easier to differentiate, our first step is to rewrite the radical square root as a fractional exponent, which is y equal x squared in bracket x negative 6 power with 1 over 2. Looking closely at this expression, we have two functions multiplied together, which is x squared and in bracket x negative 6 power with 1 over 2. This means we must apply the product rule that Izazi just explained, which is d over dx in bracket uv equal to u prime v plus u v prime. Let us declare our part clearly. Our first term is u equal to x squared. Differentiating this gives us u over 2x. Our second term is v equal in bracket x negative 6 power with 1 over 2. To find the v prime, we must apply the chain rule. We bring the power 1 over 2 to the front. Subtract 1 from the power to get the negative 1 over 2 and multiply by the inner derivative of in bracket x negative 6, which is just 1. This gives us v prime equal to 1 over 2 in bracket x negative 6 power with negative 1 over 2. Now let's substitute u prime, v, and v prime straight into our product rule formula, which is dy over dx equal to in bracket 2x multiply with in bracket x negative 6 power with 1 over 2 plus in bracket x squared multiply with 1 over 2 in bracket x negative 6 power with 1 negative 1 over 2. The question explicitly asks us to simplify our question. To do this efficiently, we can factor out the lowest power of x negative 6, which is in bracket x negative 6 power with negative 1 over 2. Now we expand and combine like terms inside those brackets. Moving the negative exponent back to the denominator as a square root and converting the decimal into a clean algebraic fraction gives us a final simplified result, which is dy over dx equal to x in bracket 5x negative 24 over 2 square root x negative 6. Now, I pass the presentation back to Afifa to walk us through our second problem, which require more implicit differentiation.
Next, given x squared y equal 2 cos x plus y minus e to the power 3y. Divide the equation into 3 parts. First, x squared y, second 2 cos x plus y, and third negative e to the power 3y. Step 1. Differentiate both sides with respect to x. First, use product rule for the left side. uv prime plus vu prime. U equal to x squared, u prime equal to 2x, v equal to y, v prime equal to dy over dx. Derivative x squared y equal to x squared times dy over dx plus y times 2x equal x squared dy over dx plus 2xy. Next, derivative 2 cos x plus y. Derivative 2 cos x plus y equal negative 2 sin x plus y. Derivative x plus y equal 1 plus dy over dx. Derivative 2 cos x plus y equal negative 2 sin x plus y times 1 plus dy over dx equal negative 2 sin x plus y minus 2 sin x plus y dy over dx. Next, derivative negative e to the power 3y. Derivative 3y equal to 3 times dy over dx. Derivative negative e to the power 3y equal negative e to the power 3y. Thus, the derivative of negative e to the power 3y equal negative 3e to the power 3y dy over dx. Next step, combine both sides. X squared times dy over dx plus 2xy equal negative 2 sin times x plus y minus times dy over dx minus 3e power 3y dy over dx. Step 3. Move all with dy over dx to left side and factor out dy over dx. X squared dy over dx plus 2 sin x plus y times dy over dx plus 3e power 3y dy over dx equal negative 2 sin x plus y minus 2xy. dy over dx multiplied by bracket x squared plus 2 sin x plus y plus 3e power 3y equal negative 2 sin x plus y minus 2xy. Lastly, make dy over dx as the subject. Thus, the answer is dy over dx equal negative 2 sin x plus y minus 2xy over x squared plus 2 sin x plus y plus 3e power 3y.
In conclusion, differentiation is an important topic in calculus because it helps us understand rate of change and solve many real-world problems. Understanding this technique enables us to differentiate various types of functions accurately.
Thank you for watching.